We introduce Codestrates, a literate computing approach to developing interactive software. We demonstrate its concepts by writing a grocery list application. Codestrates consist of paragraphs. Body paragraphs have rich text and HTML editing capabilities. Style paragraphs are used to style elements in the Codestrate using CSS. Changes to the style are immediately applied. Code paragraphs allow users to add interactivity to a Codestrate, for example, by adding event listeners to an input element. When the Enter key is pressed, it appends a list element to an unordered list. The input's value is set as inner HTML on the list element. Code paragraphs can be executed immediately or set to execute on page load. Paragraphs can be changed at runtime, for example, to adjust styles. Body paragraphs can be set to full screen, allowing for app-like experiences. Codestrates are automatically synchronized across devices. In this video, we feature 3 scenarios that demonstrate further uses of Codestrates. Alex, a teacher, is preparing an assignment for his physics class. When he finishes creating the assignment, he tags it as a stable version and sends the students a link. Jim and Bethany open the link, which automatically creates their personal copy of the tagged version. Alex also created an interactive body paragraph that lets his students visualize the data to help them understand acceleration. The smartphone adds accelerometer data to a data paragraph, which is immediately reflected in the graph. As part of their assignment, Jim and Bethany have to analyze their movement speed when walking, running, and cycling. They exploit Haversine's formula and the geolocation API. They implement code collaboratively on their laptops by accessing the same Codestrate. They also build the user interface together. It allows them to choose which type of movement they are recording into the data paragraph. Outside, Jim and Bethany collect data by recording different types of movement and can see their speed in real time. At home, Bethany starts analyzing the collected data. She adds text and variables to a body paragraph. She then writes code to replace the variables with the average movement speeds they collected. Bethany reuses her teacher's graph code to plot the data. Alex wants to hone his programming skills and decides to extend a Codestrate with video communication capabilities. First, he writes code to acquire the video from the built-in camera in his laptop and tests it. He then uses Webstrates' streaming API to stream the video and audio from GetUserMedia API to clients connected to the same Codestrate. He tests the remote video communication by sending a link of this Codestrate to his friend. To fit both videos side by side, he adds some styling to his style paragraph. Alex turns the video functionality into a system section by checking a box, which makes it part of this Codestrate's core functionality. He also wants his students to be able to use the remote video communication, so he pulls the video communication section into his assignment Codestrate. He checks to make sure the section is there and hides it. He then tags this version as the new stable assignment Codestrate. Jim and Bethany also pull the video communication to their Codestrate and use it to remotely discuss Bethany's analysis. Jim and Bethany are part of a game development club. This week's project is to develop a multiplayer tank game in a Codestrate. While playing the game, they realize that bullets do not bounce off of the walls correctly. With Codestrates, Jim can change the physics of the bullets at runtime, while Bethany continues playing the game.